Hi everyone, welcome to Module 8. This module will teach you how to run regression with R. Basic commands for linear regression and multiple regression will be provided in this video. Please get ready and let's get started. In this demonstration, we will also use the sales data of July. Let's read the dataset into RStudio by using the read.csv function. This is how the dataset looks like. There are 7 columns in the dataset, including sales, brand, customer, and trade. We are interested in understanding the relationship between two variables, sales revenue and the transaction date. In order to examine the relationship, we can run a simple regression model. Do you remember the scatter plot that we created before? The scatter plot shows that the sales is having a positive linear relationship with the transaction date. Therefore, the linear model is suitable for this dataset. After running the regression, we are able to get the exact function showing the relationship between sales and the transaction date. To do so, we need the LM function. 2 elements should be put inside the LM brackets. The first one is to write the formula with the tilde operator. In Module 6, we also use the formula y tilde x in the aggregate function. The format is the same in LM function. Here, let's set sales to be the dependent variable y and transaction date to be independent variable x, as we want to know how transaction date influences sales performance. So the formula is written as sales tilde trade. The second element inside the brackets is to specify the data set we are referring to. Since the regression model is using data, so we need to put data inside the brackets. Run this command and we can get a regression named simple. In order to view the regression result, you need the summary function. Put regression name inside the brackets and run the command. This is the result you will get. According to the summary, the R-squared is 0.92. R-squared is an indicator to show what percentage of the variable can be explained by the model. In this example, our model can explain around 92% of the variables, which is a reliable regression model. Now let's look at the coefficients. The intercept of this simple linear model is 272.258 and the slope is 30.565. Hence, the equation should be sales equals to 272.3 plus 30.6 times trade. After learning about simple linear regression, let's look at the multiple regression model. We need multiple regression model to examine the relationship between one dependent variable and 2 or more independent variables. In this example, we are interested in how transaction date, product brand, and customer gender impact sales revenue. Therefore, we will be using these 3 variables as independent variables in the regression model. Let's take a deeper look at the 3 independent variables. Trade is a numeric variable, while brand name and customer gender are categorical variables. To deal with categorical variables, you need to tell R that these 2 variables are factors, so that it will not treat them as other variable types in the regression model. To do so, use the s.factor function and put the variable name inside the brackets. To build a multiple linear regression model, we still use the LM function. While the dependent variable, sales, is still on the left-hand side of tilde, the 3 independent variables, trade, brand, and customer, are put together with a plus operator on the right-hand side. Remember that you need the s.factor function for the 2 categorical variables. Now let's specify the data source, and the command will look like this. Run the code and a summary of multiple. Then you can get this multiple linear regression result. According to the summary, check the R-squared again, and it is around 0.93, which is also a decent result. The intercept is 279.4, and the three coefficients are 30.6, 1.1, and negative 36.9. And this is the equation. One important thing you need to be aware of is the predictor of categorical variables. For the customer variable, there's a M printed after the variable name in the result table. This means that if a customer is male, then customer equals to 1 in this regression model. On the other hand, if the customer is female, then customer equals to 0. You might still be confused with this concept. Let's explain this idea with a simple example. Suppose that we have a female customer who purchased a product of brand B on July 10th. This is the estimated sales for that transaction date. We get this prediction because trade is 10, brand is 1, and customer is 0. With these three values put into the model, we can predict that the sales is 586.5 in that day. To sum up, you learned about how to build simple and multiple linear regression models in this video. There will be a review table for you at the end of this video. You may pause for a while to look at the commands taught in this module. The next module will provide you some useful resources for our learning. Please move on to the next video.